Hi everyone, in this video we're going to learn about chapter 5 semantic memory. So first, let's go over what semantic memory is, like a brief review, right? So semantic memory is the memory that is associated with facts, right? Like things that cannot be changed. Things like dates, capitals, math, arithmetic, and even events, right? Because we've seen them happen right in front of us. That's a fact. Um, so semantic memory, the basis of semantic memory is formed by things called concept cells. So what are concept cells? Concept cells are cells that encode the concept for one thing. So say I say the word like needle, right? So concept cells will activate for, sorry, I apologize. Um, Concept cells will activate for just that word, right? Will activate for the word needles. And these are found in the anterior temporal lobe. Okay, so one really important case that we're going to learn about is a guy named DBO, right? So DBO was a guy with this disorder where whatever he saw, right, he would be able to he'd be able to see it fine. But the issue is he wouldn't be able to identify it, right? He wouldn't be able to say, oh, that's a thing. The only way he'd be able to do that is he'd go around asking in the room, right? He had like his kitchen, his stove, his cabinets, his sink, and then he'd have like, I don't know, a cup. Everywhere he'd go around, he'd go and he'd touch each object and ask, oh, is this a sink? Is this a sink? Is this a sink? So he'd touch the cabinet and he'd ask, is this a sink? And when he'd touch it, he'd be able to tell that it's not a sink. But when he was looking at it, he'd not be able to tell that that's a sink. So he'd go around touching everything. And then once he met the sink, he'd say, oh, this is a sink. So what do you think might be a possible explanation for this? So for me, what I'm able to tell as a physician is that, okay, he's able to see fine. You know he's able to see fine, but he's not able to identify what he sees visually, but he's able to identify what he touches. So that means one of his communication pathways, all of his individual senses are fine. The way they're connecting back to the brain is what's hindered. So in DBO, this man basically had damage to the connections from his eye to his temporal lobe. So what does this mean? So his visual pathways, from the visual pathway, remember how there were two streams that we talked about, the dorsal and the ventral pathway? In this, the pathway that connects to the temporal lobe for object identification, right? Because that's where your memory happens. Like how I like to think about it is your temporal lobe is where all your memories are stored. So if you wanted to cross-check, all cross-reference and identify, your temporal lobe would be the crucial part of that, right? Um, the identification between your visual cortex to your temporal cortex will be damaged, right? It's not going to work properly. So you're not going to be able to, identify it properly. Uh, Oops. Okay, so this is what happened. Okay, so then the temporal lobe damage, right? So as we saw in the previous example, this man had damage between the communication between the visual cortex and the temporal cortex. So the brain wasn't able to communicate what they saw with what they wanted to remember to identify, right? So there's a similar also part in the brain that can be damaged called the fusiform face area or fusiform face gyrus. So what it is it's located at the base of the temporal lobe. So you have, say this is the base of your temporal lobe, right? It's located right about here. Let me color that in with. Okay, so it's located right about here. So the purpose of a fusiform face area is to identify faces, right? So actually, what can happen is there can be a small lesion or an area of damage in this area, which is called well, damage, lesion, right? So damage to the fusiform face area results in a really cool disorder called prosopagnosia. So let me type that out for you. It's a pretty long word. It took me a long time to learn how to spell it. But so prosopagnosia is the disorder in which a person cannot identify faces. Scientists are still debating what the person sees in the fusiform face area, because some people, the definite definition of fusiform face area is not known. People don't know if fusiform face area is required to actually identify that it's a face, to interpret that it's a face, or it takes in visual input and then the fusiform face area from that visual input identifies the face in specific, right? So people don't know what people with prosopagnosia see. One hypothesis that when they see faces, they literally just see a blank face, right? Like there's no face. Or people argue that they do see the face, they just can't identify, put their finger on it that it is a face. Okay. Sorry guys, I'm running a little bit of cold, so okay. For this video, I might just do one more. Sure, why not? Okay. So a good connection leeway, or I'll just give you guys a preview because this is a pretty long explanation. So semantic memory, it forms the basis for a lot of our processes such as reading, speaking, and writing, right? So you need to know that without the hierarchical understanding, so like concept cells connect with other concept cells to form a tiered understanding, right? So like it'll form one level and then another bigger level and then another bigger level with all the words of understanding. This is like one word understanding. This is like two words understanding. Um like this is like one egg. Say this is one egg. Your semantic knowledge, your concept cell activates for one egg. Then this level would be like, okay, one egg is associated with 12 eggs to make a dozen. So what egg and dozen will be associated with 12, right? And then this large one will be you using egg and dozen in a sentence. So the way that these cells connect together and how they form bonds together, or not bonds, sorry, I'm going through my chemistry unit and I'm just kind of confusing. So what I'm saying is the way that these cells form connections with each other forms the way that we progressively get better at using semantic memory together, right? To form better ideas. Okay, so that's a good preview. And with that, I'll stop here. Bye guys.